Hello and welcome to the best practices for application observability at scale. My name is Abhay Chauhan and I'm a solutions architect at AWS. So today I want to start with a story. So let's say there's a public-facing web application. The architecture at a high level was there's a front-end website with a mobile app, which is built and run by the front-end team. This leverages a range of APIs built by the back-end team. Now both teams start hearing reports that the system is not performing well and their users are getting frustrated. So each team pulls up their dashboards, metrics, and takes a look. So the metrics look good: CPU, memory, API calls, the number of users. None of the alarms have triggered. So naturally, each team believes their part of the application is working as expected and points to the other team as the root cause. So as this continues, users continue having a bad time and teams don't know what's causing this impact. So then a question is asked of each team. Show us the metrics for your user experience for your application. The teams didn't have dashboards, metrics, or telemetry for the user experience. Now, if I were to share the most common pitfall I see in observability, it's exactly this. It should all start from the user experience because that's what really matters. I'm a specialist in observability, so I've worked with many customers on their observability journey. I've listened to tens, if not hundreds of customers about their learnings, including our own Amazon teams at scale, and that's what I want to share with you today. Let's start here. What is observability? So taking the example of this application, we have a customer on the left and the service on the right. So simply put, observability is being able to observe this interaction and everything it involves to answer the questions about what your customer or stakeholder cares about. It's about knowing about issues before they happen and before your customers have to tell you there's an issue. So for example, which specific user actions are causing errors or slowing down your application? How did the recent changes to the application affect its performance? So if search was important to your customers, what is your search latency for your enterprise customers? Or how effective are your search results? These questions can vary between applications and systems, but the key is observability should be able to answer the important questions. Observability matters because at Amazon, we strongly believe observability is a day zero problem. We obsess over it. Observability matters because we build systems to run over a long period of time. We're going to update and change that system a lot, and we need to know what it's doing, how it's performing, and if it's really solving the customer's problem. We need visibility over the system. This includes when things go wrong. Things always fail, so we need a system that makes it easy for us to troubleshoot. But let's take this further. It isn't just operational. It also should drive value for your business as well. We build systems to solve problems, our customers' problems, and their experience using the system matters a lot. We need to ensure the system is providing a customer with a great experience. Now a step further, we're hearing a lot about customers really innovate based on their system observability, using it to drive a strategic advantage for your company. In a recent Gartner report, I was reading about an insurance company that was leveraging observability to provide discounts on car insurance premiums. They can observe how safe you drive using sensors and cameras on the car. The reality of modern applications is that they have become a lot more powerful and a lot more complex. We have microservices, we have event messages, we've got APIs and databases. We want to monitor, build deployment pipelines, and so on. In the context of it all, having great observability becomes a necessity. You need great instrumentation to interrogate, to correlate those answers to those important questions. Now, AWS, we provide you a couple of things to help you with that. AWS Observability, that includes AWS native, application performance monitoring, and managed open source services. There's a lot to this slide, but the key takeaway here is there's a range of capabilities on the native side with metrics, logs, and traces. There's real user monitoring for your front-end user experiences and synthetic canaries too. On the open source side, we've got Grafana, OpenSearch, and Prometheus, just to name a few managed services. Now this talk is focused on the best practices in observability at scale, but I'll use AWS services as an example. You should be able to take any of these best practices to any observability platform that you use. So let's talk about the important metrics. CPU, memory, and disk metrics are core measurements of any system. These metrics are important, but are they actually important to your business and your application? I've lost count of the number of customer discussions I've had where metrics were the centerpiece of their dashboards or alarms. Should I care about these metrics? Do they tell me anything about how the application is running, or more importantly, do they give you any insight into the customer's experience? So let's go back to this diagram, which I used to introduce observability, but let me add one key highlight to this diagram: the user experience. In this section, I'm going to cover some grounding on how we think about observability in Amazon, some of the places we use observability systems, and the mechanisms we use to drive the flywheel of improved customer experience and operations. I like to think of observability as measuring and empathizing with our customers, which are seeing and using our services. So starting from the top, our leadership principles. We start with the customer and work backwards. Work vigorously to earn and keep customer trust. Leaders pay attention to competitors but obsess over customers. So how does this translate to observability? So when you think about observability, you should think about what your customers want and what they need. In this case, it's a context of Amazon e-commerce site. So customers care about delivery. You want your stuff to be delivered quickly, or at least know when it's going to be delivered. They obviously care about the price. They care about security and privacy. You care about how long a page takes to load, and you also care if you can find the product you're actually looking for. So there's a Forrester research report that said 43% of visitors, when they go to a site, they'll go straight for search. And searchers, they're 2 to 3 times more likely to convert compared to non-searchers. So search is really important, and it has to work really well. As technical people, we might not know what the customer requirements are, but the stakeholders, it's their job to know. Work with them to nail down those KPIs. And once you identify those KPIs, you identify the metrics which you'll be collecting by instrumenting. Once you have the metrics, you can start alerting, and you can act when the business outcome or the customer experience is at risk. Then once you've had to act, you can make improvements based on what was wrong. This improves the customer experience and creates this virtuous cycle of continuous improvement of the customer experience. And that's what's really important here, is that you can't do continuous improvement without this data. Now let's get into the details of the best practices. First, let's talk dashboards. Every sizable customer that I've worked with has invested in building out dashboards. At Amazon, we love our dashboards too. Every team within Amazon has dozens of dashboards. So in this session, I'm going to discuss what we think about dashboarding in Amazon. Dashboards are critical to show you quickly what's happening within a system through a particular lens. So for example, a stakeholder or a product manager would want to see a dashboard focused on the user experience. The most common mistake I see is dashboards, the eagerness to add lots of information to them. I see dashboards used most importantly during an operational event. So keep that in mind when designing dashboards. Keep them simple. During operational events, people frequently assume different roles in the process of resolving an issue. Having top-level view of a customer experience is a great starting point. It allows business leaders to effectively communicate with our customers, and also tech teams to see if the actions they're taking is actually improving the customer experience. A good customer experience dashboard focuses on key customer experience the service offers, but also makes it very clear in terms of breadth and depth of the customer impact. The entry point to our web-based services is typically through UI or API endpoints. So having a dedicated system-level dashboard that contains enough data for our engineers to see how the system's operating and its customer-facing endpoints are behaving. We also build microservice dashboards to facilitate fast evaluation of the customer experience within a single service or cell or partition. So this narrow view ensures that our engineers are not distracted by irrelevant information during an operational event. It also is important to have a view of the microservices that might be dependent for particular function. We also have dashboards that enable our teams to view the amount of resources or services they're using. This allows them to do longer-term capacity planning and forecasting of their services. So for example, to ensure they've got enough compute and storage. So as you can see, there's lots and lots of dashboards. In fact, there's a lot more than I'm showing here. But the key thing is that it makes it easy during operational events. because they're going to happen at 3 in the morning. You quickly have the data at hand that you need without having to search for the right metric, which can be very stressful. Each dashboard has its clear purpose and focus. So now let's talk about the dashboard design. At Amazon, we've been building dashboards for decades. So during this time, we've learned what works best for our teams, and I'm going to briefly highlight some of these key points here. We found that using time series graph works best for our teams. This allows teams to visualize when performance of a system has changed and also by how much. We ensure we could place the most critical data at the top of our dashboards, such as availability, latency, and request rate. Less important metrics can be placed lower on the dashboard. During an operational event, which can happen any time of the day, we want to make it easy for our teams to see all the critical data. So we want to make sure all the data is visible on dashboard without scrolling. Time zones can be tricky. We're a multinational company, we operate in different regions, and so do our customers. So again, we use consistent time zone on our dashboards, which is really useful. So in this example, we're using the UTC time zone. We also annotate our graphs with SLAs and SLOs, so our teams can understand what good looks like for a specific metric. You can't assume you're the only person using your dashboard at a specific time, so make it easy for your teams by adding descriptive texts to your dashboard. We want to make sure that we don't overload the y-axis by having multiple time series that are on different scale. It's not very useful when it's not readable. Keep it simple. Don't overload these dashboards with tens of graphs. Create multiple dashboards if you have to. One of the key things is you don't want to go fishing for metrics during operational events. So build a set of detailed dashboards in advance before your services go live. It's important that you can get things you've learned from previous events into your dashboards, which is why it's critical to build a culture of continually inspecting and refining your dashboards. So one way to do this is manage your dashboards programmatically through infrastructure as code approach. At the beginning of our weekly operational meetings, we select 2 services in our meeting to audit randomly. So this random approach works well for us because it ensures that each of our teams are prepared to speak to their dashboard during operational reviews, which in turn requires them to be ready proactively. The next best practice, capturing important telemetry. Capturing important telemetry at Amazon, we do that for every application and service. So for every unit of work or request it's doing, we collect telemetry and we put that into a log. Generally, it's emitted as 1 log entry per unit of work, whether that's HTTP request or a message pulled from a queue. It's in a structured log like this. And at Amazon, we call this a request data log. So how do we build this out? Let's take a step back and look at the instrumentation for this log. So let's say we have some kind of e-commerce site, and this function gets product information that we use on our site. If this is the code that I implemented, then I try to operate this at scale. When something goes wrong, I'm going to have a lot of questions and I need to know what is going on. Why did this request fail? Why is this being slow? I don't have any sense for what this request was trying to do or who it's for. Did this request make it to cache? Did it get anything useful from the cache, or did it have to go back to the database? If it did, if either of these things failed, why? Were they timeouts? Because timeouts are very different. Did the database take a long time to query? Did it return anything? There are so many questions that this code by itself doesn't help me understand, and I won't be able to operate this thing effectively at scale. So what we do at Amazon doesn't actually add too much code, but it's some really important stuff. Amazon, we use a common metrics library all throughout the company. And that metrics library, whenever the service gets a new request, it creates a new object, a new instance of the metrics object. We pass that all throughout the code. We pass this metrics object around to the cache library or SDKs for the remote call. And those libraries also speak in terms of this metrics library. So they can add instrumentation automatically to the request. And so we just keep getting more and more instrumentation as the request gets processed. And that happens pretty much automatically, because our different libraries and SDKs are all participating with this metrics API. But then in my code, I'm also going to add facts. I'll say what the request was working on so I can tell later when I'm trying to debug it. And so all of this instrumentation, when it comes from all this code, it gets written out. And so you can see there's lots of information about the request. That's going to be useful to understand what happened. There's like who made the request, where did it come from, there's a trace ID, there's information about the infrastructure that processed the request, instance ID, availability zone, which cache node did we work with? And then there's a bunch of timing and other measurements. about how long did things take, how many things did it process, and things like that. If we break it down more generally, there's measurements, which are about timing, the numbers and the facts of whether things happened. And then there's attributes, so strings. So there's timings, which is number, and string, which is attributes. And next, we can introduce the embedded metric format, which allows us to select properties in our log to convert to metrics. And that's what this part does, the metric definition. It provides the namespace where the metrics will be grouped, and it says, I want to take the time property and turn that into a metric. Okay, so what does this look like? Let's say we're plotting something. These concepts apply to any kind of tool that you're looking at, but we'll take CloudWatch as an example. This was our embedded metric definition in our log. The log was for the product info service, so it's going to define our namespace. There are no dimensions, and we're going to use the time attribute from the log. So these units to display for the metric. And then we actually have the measurement, which contributes to the actual line. Fantastic. So now we have the metric, but now we see a spike in that metric. The product info service has become slow. So this metric doesn't help us understand why. It just tells us that it happened. So how do we use these metrics to find out why? Well, let's take a step back and look at our architecture for the product info service. For the product info service, we have different operations on the API. For example, getProduct would use a simple key value store like DynamoDB. And then there's updateProduct API, which uses a queue. And then there's searchProduct, which uses a search index. Each of these APIs has its own set of dependencies and things that can go wrong. So ideally, we want to separate each of these operations. This is where metric dimensions comes to be useful. So ideally, we have something like this. It's still grouped by the product info service namespace, but we have time metrics grouped by each operation: get, search, and update. How did we get this? So going back to our log, we need to add the operation for every request, an attribute that says, this is the API name that I'm currently working on now. And then in the embedded metric format configuration, you can specify the dimension as the operation attribute. So whatever you find in this operation field, whatever string I'm going to put in there, makes it its own distinct metric. And that's what you see here. So dimensionality helps us dig in a bit lower. And this enables us to capture rich telemetry from our application, including custom business metrics, and convert these metrics into measurements for your dashboards and alarms, giving you much greater visibility and understanding. Other observability platforms have their own approaches to capturing metrics at scale. But for this metrics library I spoke about, this is an open source client library called Embedded Metric Format. You can try this yourself. I'll share a link towards the end of this talk. Now the next, alarms. Let's get on to designing alarms. So when we're coming up with our alarm alert strategy, be very deliberate about what you alert on, because you'll have a massive impact on your business outcome. Alert fatigue and alarm noise can be real business impacting issues, because if you have too many alerts, it becomes really easy to miss something important. Alerts must be actionable. Why would you have an alert if you don't want to take an action? So back to the 3 a.m. rule. If you get this alert at 3 a.m., would you read the information, turn over and think, I can sort that out tomorrow? If so, perhaps it shouldn't be an alert. Define expected actions through the use of playbooks. So anyone who's responding to that alert, no matter how long they've been with the organization or how well they understand the business or application, it's so they know exactly the process they're expected to follow. And then where possible, remediate with the use of runbooks for automated or semi-automated remediation. Let's talk about reducing alarm fatigue. This is the first thing that I would really think about when you need to focus on alarms. Focus on your key performance indicators and your workload metrics. You can imagine a very high volume e-commerce website might really want to care about or how many orders are being processed, or the page load speed, maybe the search latency. What is the important metric for your service or application? One of the most powerful and easiest things you can do to get started on creating better alarms is to use synthetic testing. We call this CloudWatch Synthetics. It's simply a headless Chrome browser. It automates a bunch of user actions and records screenshots and metrics for you to analyze or alarm on. I'll give you a little peek at this in a demo coming up soon. Alert when your workload outcomes are at risk. Use the 3 a.m. rule that we've mentioned a few times. Consider creating alarms on dynamic thresholds instead of static thresholds. For this, you can leverage CloudWatch anomaly detection. Anomaly detection applies machine learning algorithms to your metrics pass data to create a model of expected values, which understands your seasonality too. So when it sees anything unexpected, it'll let you know and correlate your alarms with composite alarms too. So in CloudWatch, we've got composite alarms. Other observability platforms have a similar feature, and they allow you to use and, or not operators to combine multiple metric alarms. An alarm I see too often is on CPU. CPU alerts are not great. Is this worth waking up at 3 AM for high CPU? High CPU with an increased page load time or timeouts for the user, now that's something worth alarming for. So where possible, create meaningful alarms with composite alarms. Now in this section, I've mentioned a handful of features in CloudWatch, which means it's time for a demo. In this talk, we've spoken a lot about best practices that aren't tied to any observability platform. I'm going to switch modes now and show you these examples using AWS native tools. So in Management Console here, I'm going to head over to CloudWatch. And now while that's loading, we've mentioned a lot about the user experience in this session. And the first two capabilities I'm going to show you are focused on just this, the user experience. On the left, I'm going to scroll down in CloudWatch and click on RUM. So RUM stands for Real User Monitoring. And this AWS service is made to capture telemetry from your user's browser. So as you can see, it gives us a whole lot of information. We've got information about page loads, page load speed. We've also got the app deck score, which is a score of your application's responsiveness for your application. We've got the app deck score by location. So how is the user experience across the globe from the traffic where it's coming from? You can see page load times and load times around analytics for devices and sessions. So I'm going to head into the monitor itself, which is going to give us a lot more information. So here we've got performance information. I'll come back to this in a moment. We've got telemetry on errors captured in the browser. We can capture errors in terms of JavaScript errors and HTTP errors from the client's browser, which is very useful because it does impact the user experience. We've got session information and custom events. We can capture analytics around the browsers and devices and things like that as well. But for now, I'm going to go back to performance and then click on this page button. So this page button basically allows us to see performance data grouped by the pages. I want to see highlight here that we've got category cookbooks page, and we can see there's a red mark on it because the page load time for this is quite bad. I'm going to select on this to investigate. We can see the page load speed is over 10 seconds, which is very frustrating and also highlights by all these red blocks. If I scroll down, we can see the web vitals captured from the browser, as well as page load steps over time. So this breaks down the page load number of steps in the browser has to take. So for example, DNS lookup, SSL negotiation, downloading content from the servers, but you can see here the third last line, document object model processing time, which takes about 10 seconds, the bulk of this page load time. That's what's doing a lot of the processing. So the processing for the HTML and the JavaScript content, and it's executing the JavaScript logic as well. The bulk of the time is being taken up here. So there's probably some sort of performance issue in this section. So to investigate and solve this problem, I'd look at those areas for the page. The great part about all these metrics that we're looking at here, all this data, it gets pushed to CloudWatch metrics. So you can create dashboards and trends over time. So now I'm going to switch over to a service called Synthetic Canaries. Now, Synthetic Canaries is code written in Node.js or Python. It allows you to automate a headless Chrome browser. It automates a user's actions through code, essentially creating synthetic traffic. So I've got a canary here. I'll show you an example that's written basically to place a random order automatically for me. Similar way that a user might on my website. So we can see the canary has 6 steps. It comes to my bookstore, it logs in, it clicks on a random category linked, it adds a random product to the cart, it checks out and pays, and then waits for the purchase to finish. We can see the status of these steps that's passed or failed, the URL, the duration, and the screenshot. So if I can scroll down here, I can see all the screenshots that were taken before and after. I've also got the technical logs of what's actually happening and the request details and the timeline associated to that. So you can see what sort of HTTP requests were involved in this canary. But my favorite part about this is the monitoring tab. it gives us a rich amount of information for this workflow. So for example, we can see there's a duration. How long did it take to complete this user workflow over time? We've got a bit of fluctuation here, but we can see the information. We can also see the success percentage. We can see this duration of each step in our workflow that's captured and recorded as well. We can actually isolate which steps are slow and which ones are performing well. There's a step success, and there's information about our web requests as well. So as you can see, there's a plethora of telemetry that's captured from the user's experience using this synthetic canary, which once again is projected into CloudWatch metrics for our dashboards and alarms as well. So it's a very useful tool to create that synthetic traffic and capture what's really going on with our website. Now I'm going to switch over and take a look at the duration metric in CloudWatch metrics. So as you can see, there's a bit of fluctuation going on here. We've got the duration fluctuating from around 22 seconds all the way up to 35 seconds. There's a bit of fluctuation up and down, and if I click on this alarm icon next to the metric, I can create an alarm for this metric. To create an alarm, we need to think about threshold. So normally I see a lot of alarms based on static thresholds. So for example, if I want to trigger this alarm when it goes over 35 seconds duration, I can set that threshold. Anytime it breaches that red line on the graph, it will trigger. But on the other hand, you can also leverage dynamic thresholds that we mentioned earlier, called anomaly detection. And what this does is it analyzes the historical data and creates a model of predictions based on the seasonality and what it sees. This includes basically that gray area that you see. It's simply a preview of that. So as you can see, those red lines at the top would be a breach. That's from the expected range from the alarm, and that would trigger the alarm. And once again, you can modify how many standard deviations that should be based on. So if I want to be a bit more generous or giving, I can change this to 4 standard deviations, which would require bigger anomalies to trigger that threshold. It's a dynamic way to understand the seasonality of your data and create that dynamic understanding for the alarm. Now let's jump out of this, and I'm going to head over to alarms and show you the last capability, which is composite alarms. So I've created a composite alarm here. A composite alarm is where you can create an alarm that monitors other alarms. So you can create a tree structure. Quite a number of alarms can be leveraged using this Boolean logic or not logic between them. So for a concrete example here, I've got 2 child alarms. I've got a purchasing canary duration based on the anomaly threshold, which is the alarm that we were just looking at, and I've paired that with a simple API latency alarm. So that my alarm rule is when the canary duration triggers, and also when the API latency gets high, I'm going to trigger this alarm. This would be an ideal alarm to be associated with an alert, because when it's taking a bit longer than usual and the API latency is also getting slow, it's time to take a deeper look. Now let's take a step back. We've looked at a couple of user experience capabilities in CloudWatch, namely real user monitoring that gives you visibility into the user's browser and their experience, and synthetic canaries, which allows us to create automated synthetic user traffic. Also in terms of alarms, we've looked at anomaly detection for those dynamic thresholds, as well as composite alarms to reduce alarm fatigue. These are capabilities I see being used at scale a lot and provide a lot of value. So to summarize, work backwards from your customer. What are they interested in, and how does this system impact their objective, what they're trying to get done? Dashboards should always be built for a particular persona or lens. Keep them simple, focused, and continue to invest and iterate over them. Telemetry. Capture the right information from your code and leverage embedded metric format to selectively convert those metrics and enable alarms and dashboards. Alarms. Leverage composite alarms with the user experience to reduce alarm fatigue. If one alarm goes off, it might be noise. If multiple trigger, something's most likely going on. Also, I mentioned resources earlier. So in regards to embedded metric format, a model we use extensively in Amazon to capture request data logs and selectively convert those properties to metrics and dimension. Amazon have a range of client libraries open source, so you can leverage and help you to get started quickly. For those of you who are interested more in this topic, dashboarding, John O'Shea has written an excellent Amazon Builders library called Building Dashboards for Operational Visibility. Please do check it out. And another great Builders library article I want to share with you is Instrumenting Distributed Systems for Operational Visibility. If interested in how to instrument your code internally, this article goes into much more depth. And that's a wrap. And if you'd like to dive into more self-paced learning, check out the skillbuilder.aws website. Please also complete the session survey. It provides me and the team behind the scenes with valuable insights and feedback to help us improve these sessions.